Okay, in this video, I will explain on the crystallization of sugar. So this is also one important subtopic in Learning Unit 4, Carbohydrates. So important characteristic of sugar is rely on their ability to form crystal. So in the commercial production of sugar, crystallization is the most important step. To purify a sugar, meaning the purer a solution of a sugar, the easier it will crystallize. And in some food, crystallization is undesirable, meaning we do not want crystallization to occur, such as crystallization of lactose in sweetened condensed milk or ice cream. Okay, so crystal growth can be classified or can categorized into two steps. The first one is the mass transfer of sucrose molecules to the surface of the crystal, which is the first order process, and the second order process involves the incorporation of the molecules in the crystal surface. For lactose, crystallization can occur in two forms. The first one is the alpha hydrate and the second one is the beta anhydrase form. So the most common form is the alpha hydrate, which can be obtained by crystallization from a supersaturated solution below 93.5 degrees Celsius. When crystallization is carried out above 93.5 degrees Celsius, so the crystal form are anhydrous type. Have you ever wondered why it is anhydrous when it is heated above 93.5 degrees Celsius? Okay, you can think the clue is on the boiling point of water. Okay, the solubility of lactose also less than most other sugar, which may present problems in a number of foods containing lactose. For example, if a milk is concentrated 3 to 3/1, the concentration of lactose approaches to its final solubility. So when this product is cooled or when the sucrose is added, crystal of alpha hydrate may develop. And such lactose crystals are very hard and sharp. And when left undisturbed, they may develop to a large size, causing a sensation of grittiness or sandiness in the mouth. You know, when you have a crystal, for example, crystal in a milk, they just need one crystal. So when you do not disturb the solution, the crystal will continue to grow. Then when it grows, it will become bigger, and when it is bigger, it will become harder and sharp. So this will cause a sandiness in the mouth. The sensation is just like when you taste a rock candy, yeah? The candy that pop in your mouth. Okay, that is the feeling of tasting hard crystal, yeah. And this phenomenon limits the amount of milk solid that can be incorporated into ice cream. That's why when we produce an ice cream, if we do not want the ice cream to be feel sharp, so we need to limit the amount of milk, meaning we do not add too much lactose into the ice cream. Then this is a diagram or a figure of a crystal of alpha hydrate lactose. Yeah? So it usually form in a prism or tomahawk shape. Okay, if you look at the tomahawk crystal, so after some time, it will grow a lot. This is like one single unit cell. So if you have more crystal, so you see the prism here, the tomahawk shape will be increased with getting more, and then it will cause the sharp sensation in your mouth when you are eating ice cream. Okay, crystallization can occur in three different phases. The first one is the heating phase. So first one, the concentration of sugar in solution is increasing due to evaporation of water. Okay, let's say you have sugar here. This is your water, 50 ml water, and you have 25 gram of sugar. Okay, you heat this one, you heat this, and then some water will evaporate. Okay, and you heat it until the minimum amount of water left to dissolve the sugar. Let's say you heat until it become like 20 ml. Okay, but the solution is still colorless, because the sugar is still inside there. Uh, okay, and then after you heat, you cool the beaker. For example, you cool the beaker, so no change in the sugar concentration, but there is a decrease in the temperature. Let's say this one just now 100 degree. When you cool it down, it become around 40 degree. And at some point, a unique combination of concentration and temperature, the solution will become saturated. Okay, the solution will become saturated. And after the temperature drop below the saturation point, so every crystal has their own saturation point, so the solution becomes super saturated, contain more dissolved substance that can be dissolved. Okay, after a while, the solution becomes super saturated. So once it becomes super saturated, the crystal will come out. Okay, that this is not just applicable to crystallization in food, but it also applicable to crystallization in many things. For example, if you are doing some organic chemistry work, you are doing crystallization in the lab to get a more pure compound, so you can also apply the same concept of crystallization. Once it forms supersaturated, the crystal will come out. Okay, so this is how crystal formation can be seen. Yeah, first you have, but when should we induce crystal formation? Okay, at a relatively high temperature or at a relatively low temperature. Okay, the answer depends on understanding about sugar crystal growth. Okay, but the concept is very simple. You heat your sugar with water, and then you reduce the volume of the water, and then you cool it down and let it stay there until it reach supersaturated solution, and then the crystal will come out. Okay, if you look at this is the animation of how sugar crystal grows. Yeah, so this is sugar. So after some time, it will getting bigger and bigger. Okay, so how do we induce crystallization? Okay, we induce it here. We induce it here. Okay, then we have a small crystal, and we have the bigger one, and the biggest. Okay, so large crystal will have a coarse texture, meaning you can feel it. Okay, but when you induce here, okay, so it will become small, and the size is not that big. So it depends on uh, the size that you want. So if you want a big crystal, then you should induce at this point. If you want a smaller one, you can induce it at the later stage. Okay, so this will give you, if you induce it at the later stage, so it will come out, the crystal that come out will be smaller one and a bit smooth compared to the large crystal. Yeah, crystal size and texture is very important in food products, but it depends on what kind of the finished products that you want. So the crystal size and texture is very important in candy and frozen dessert, because the crystal size determines the texture of the product. So large crystal will give you a coarse and crunchy texture, as what you can observe in pop candy. Okay, because you want to feel the crunchiness of the crystal. Okay, small crystal is very useful in product that have a smooth or velvety texture like ice cream or yogurt. Okay, you want the texture to be smooth, so you don't want any coarse structure, so you need to have a small crystal. Okay, that's the end of this crystallization video, and tune in to another video for the next subtopic.